Number 24, in the circle above, AB is a diameter, so it's passing through the center there. If the length of arc ADB, that's ADB, that's a full semicircle, is a pi, what is the length of the radius? So the circumference length we know is C equals 2 pi r. So half the circumference of a circle, which is what we have in this case for the arc, must equal pi r. Divide the full circumference by 2. We're told that arc length equals 8 pi. With pi's canceled, divide through by pi. R equals 8. What's the length of the radius? That is 8. The correct answer for 24 is C. 25. F of x is 2x cubed plus 6x squared plus 4x. G of x is x squared plus 3x plus 2. The polynomials f of x and g of x are defined above, as we just mentioned. Which of the following polynomials is divisible by 2x plus 3? And note our answers are not just f of x or g of x. It's a operation between the different polynomials. They're added, they're multiplied and added, etc. So some operation here will be divisible by 2x plus 3, some function of the functions, and we've got to figure out what that is. So that's a little bit tricky. First thing we could check is if, well, it doesn't help us to check individually through polynomial long division or similar methods if each is divisible by 2x plus 3, because none of the answers is individually f of x or g of x. And in fact, they all include f of x and g of x, so if both of them were divisible, then every answer will be divisible. So that's not going to help us. That's not a useful approach. Another approach we could take is we could literally add in the polynomials, multiply and add the polynomials to get the fully multiplied out version of h of x, p of x, r of x, and s of x. So that'd be something like f of x plus g of x. I would then add the x squared plus 3x plus 2 to the 2x cubed plus 6x squared plus 4x. And then I'd combine my like terms, and then I would check if it's divisible by 2x plus 3 using my factor theorem or polynomial or synthetic long division, whatever method. So in theory, that will work. In practice, that's going to take a heck of a lot of time unless my answer is one of the first one or two answers that I check. I think we can find a better way here. What can I do? Well, the next thing I might try to do is factor these polynomials. And not just binomial factors, which I can see, they might have some of the same factors. I want to pull out common factors first. So out of f of x, I can pull out a 2, and actually I've got an x factor in every term of f of x, so I can pull out 2x. That leaves me x squared plus 3x plus 2. Now, I might notice something. X squared plus 3x plus 2 is g of x. It's the same thing. So really, f of x equals 2x times g of x. Well, that's important because now that I add f of x and g of x's, I'm really just adding up g of x's if I put them together. So now I need to find the one that's going to have, a 2x plus 3 as a factor. So let's look at A now. That is f of x is 2x g of x plus g of x. Factoring out g of x, that's g of x times 2x plus 1. Okay, well, that doesn't tell us 2x plus 3 is a factor, but now I see which one will be. A is not correct, but it looks like I need to get that 1 to be a 3, so I need to multiply g of x by 3. B looks like it's going to be our answer. P of x is f of x plus 3 times g of x. So f of x is 2x times g of x plus 3 times g of x. Again, I'm going to factor out the g of x's. That gives me g of x times what's left in the parentheses is going to be 2x plus 3. which means that is p of x. P of x will be divisible by 2x plus 3. The correct answer for 25 is B. This is a really interesting problem on functions of functions.